So, as you can see, my room is already a mess, and it's only Monday. I guess it's just gonna be one of those weeks. So, last week I did two things. One, I did a double digest. Two, I ran said double digest on an electrophoretic gel and excised the desired fragments and purified them. Whoa, what? Okay, so one, I did a double digest. A digest is any time you take enzymes and you use it to cut DNA. So, logically, a double digest is when you take two different enzymes and you use it to cut a DNA fragment twice. So, if I have a plasmid, which is a circular ring of DNA, and I cut it twice, it's going to yield me two fragments. In this case, I got a big fragment and a small fragment. Now, I ran this double digest with both my plasmids, and they're of similar size, so both my plasmids yielded big piece, small piece. Step 2. I took those pieces of DNA that I cut up and I ran them on what we call a gel. A gel separates DNA fragments based on size. So when I ran my piece of DNA on this gel, I could tell which pieces were the larger pieces, the long ones, and which ones were the small ones. Now I only wanted one big piece and one small piece, so then I could later connect them together. I'm taking the big piece from one of the plasmids, one of the circular rings of DNA, taking the small piece from the other one, and then today, in a different story, I combined them. Okay, enough of this science jargon. Let's just teleport over to the lab and I'll show you around. Let me put on my teleportation glasses. Go. Down what appears to be a dimly lit corridor, I promise you it's not, is the marine biology lab. This is the bench where I work at most often, and here is where I plan out my mad science tree. Is that a word? I don't know. Here's the other side of the bench, which I sometimes do some work. And here's the bench where we do our gels. In here, we freeze our DNA samples at minus 20 degrees centigrade. You can tell there are a lot of different projects and boxes in there. We have some artwork in the lab. This painting here is one that I made. But let's get right down to the science. There's my gel, and here are my DNA samples, which I'm going to mix here. The first step to my gel is adding a ladder, and that will allow me to compare DNA sizes later on. And then next I need to take my DNA samples and add what is called loading dye to them. It's this blue little stuff right here I'm injecting onto that piece of plastic there. And this loading dye will not only bind to the DNA and fluoresce under UV light, but it'll also make it sink into the well. So here's my DNA sample, and I'm going to mix it with this loading dye here and pipette it up and down several times so that it actually mixes. And once that all mixes nicely, I'm going to move it over to the gel and inject it. Mess up a little bit there on the gel. And then I'm just doing the other one for the other sample, doing the same thing, although I'm moving very quickly here, as you can see. And adding that to the well too. So now that all my samples are there, and I'm all ready to go. So let's close this up, make sure everything's connected right, and turn this bad boy on. And we're off very slowly, but you know. Now, after my gels run for as long as it needs to, I bring it up to this room here and throw it onto a UV light. And I throw the switch on, and look at that, there's my DNA. This time, I only wanted those two pieces of DNA that you can see by themselves to show up, and it worked well. The bright one is the longer piece of DNA that I'm going to use, and the one on the bottom that's not as bright is a smaller piece. So I'm going to cut these guys out and use them. But I want to record all that hard work, so I use these steps to take a picture of my gel, and then I will edit it on the computer. So there I have my picture of my gel, and I'm gonna do some little alterations to it so then I can print it out, cut it out, and put it into my notebook. And then the printer, if it's nice enough, will print out my picture for me, and there it is, looking very fancy. And that fancy little picture then goes into my notebook, so then I have documentation of what my DNA looks like for further experiments. So running a gel like that is something I do quite often. It's pretty standard, and it allows me to check up on my work to make sure I'm doing things right. It can be a little nerve-wracking though, going up to the UV room to plot my gel down, turn on the UV light, and see if my DNA project worked. because with the flick of the switch, you know almost instantly if your experiment worked or didn't work. Thankfully, this time it worked. When I cut my piece of DNA out and purified it, I ran them on the gel, which is what you saw, and then I saw, hey, my experiment worked. The piece of DNA that I isolated are good to go for my next part of the experiment. But that's that. So thanks for watching. I hope you enjoyed seeing some video of lab in action at Clark University. I will post more videos soon with my lab mates to see what we do in lab on a daily basis. But in the meantime, I'm going to go study like a good little boy. I hope you all have a great day or morning or night whenever you're watching this on the wonderful world of YouTube. TTFN. Bye for now.